So now that we've learned to write chemical formulas for ionic compounds and we know what an ionic compound is, it's anything with ions in it, and we began by saying it's metals bound to nonmetals, but now we say, well, it could also be anything that has a polyatomic ion in it would also be ionic compounds. And now that we know how to recognize them and write the chemical formulas, we have to learn how to name them. So this is an overall flow chart where I'm sort of talking you through it. And we can separate basically the chemical formula into the positive part and the negative part. There can only be two types of ions in any ionic compound, the positive one and the negative one. That's not 100% true, but it's true for our course. So you really want to sort of characterize what does the positive ion look like and name it, then characterize what does the negative ion look like and name it. And again, that positive ion could be a polyatomic or it could be a metal ion. For the negative ion, it could be a polyatomic or it could be a nonmetal ion. So I'm going to identify which one it is, and then I'm going to name it. For the positive ions, if it's just a metal ion, we will name it by the element name. If it's one of those ones that can be more than one charge, we need to figure out what its charge is and include its charge in Roman numerals. If it's a polyatomic, we use the reserved name for the polyatomic. On the negative side, I do the same thing. What kind is it? Is it a polyatomic or is it a nonmetal ion? If it's a nonmetal ion, I'm going to use the element name of the nonmetal, but change the ending to IDE. If it's a polyatomic, I'm going to use that reserved name. And you are going to have to practice using backwards math to figure out if it's one of those ions, metal ions, that is capable of more than one charge. You're going to have to use some reverse math to figure out which charge is the one in this neutral ionic compound, and then include that charge in Roman numerals. So this is sort of an overview. Again, we have our cation and our anion name. So it should basically be two words for every ionic compound name. In this case, aluminum is my positive ion, that's my cation, and it's a metal. I look at my tables to see, is this one of those metals that's capable more than one charge? It's not. It's only going to be +3, so I don't need to indicate its charge. And then the anion is a single nonmetal, so it's not a polyatomic. So I just use the element name, nitrogen, but I change the ending to IDE. On the second one, I have a polyatomic for my cation. I just use its name, ammonium. For the anion, that's chloride, chlorine, and it's just a single nonmetal, so I change the ending from "ine" to "ide." When you have a polyatomic, you have to sort of figure out where it is. What is the positive part? What is the negative part? So if you see three different elements in there, you may have to kind of look at your polyatomic chart and say, okay, which one is it? Is NH4 the polyatomic, or is H4Cl the polyatomic? So you kind of look through and you're like, oh yeah, NH4 is it. So that's how I was kind of break it up. Same thing here. I see CuSO4. I recognize, oh, SO4 is a polyatomic ion, so I'm going to break it there. So my copper is my positive ion. I'm going to call it copper. But when I look on that table to see what charge copper is, and can it be more than one charge, it can sometimes be +1 and sometimes +2. So I need to use some reverse math to figure it out. If I look up sulfate, it is a negatively 2 charged ion, and since there's one of them, remember that 4 is only talking about the oxygen. If I wanted to know how many of the sulfates are, if there was more than one, they'd have to be in parentheses and have another subscript. So since there is none, that's 1 sulfate and 1 copper. Since the sulfate is -2, the copper has to be +2. That's how I determine the charge of the copper, and I write it in Roman numerals. And then the anion name is, since it's a polyatomic, I just find the name on the chart. It's called sulfate. So we get the idea of how this works. There's a lot of little steps and decisions to be made. It's tedious, but it's formulaic. That means like there's a set of steps, and if you follow the steps, you'll get the right answer. And if you practice following the steps, it starts to become second nature and you can do it much more quickly. We are also going to talk a little bit about acids. And for now, I just want you to realize that there are things that begin with the letter H. So if I see the chemical formula begins with H, it's an acid, and we can basically memorize them. I have a portion later on where I'm going to talk about acids, so I'm going to skip this slide. Big idea that you need to be careful about when you are naming ionic compounds is to make sure it's ionic. So sometimes you can get tricked and you're trying to name a covalent compound by ionic rules. It won't work. These rules are designed only for ionic compounds. So I want to make sure, does it begin with a metal or does it begin with ammonium NH4? And if so, then I'm good. Also, I want to look for polyatomic ions and group them. So even if I have to kind of put an extra parentheses around them, so I kind of treat them as one unit. And I think about them as terms one thing with one charge and one reserved name. That will help. If I have a chemical formula that has 3 different elements in it, it's indicating something in there is a polyatomic ion. Because if it's just a metal and a nonmetal, there's only 2 elements in it. And then I have to be careful to figure out what the charge of the cation is, the metal ion is, if it's one of those metals that we call them divalent or multivalent, that is capable of more than having one charge. Those would be the ones on the reference table in the selected transition metal ions. Those are the ones that sometimes can have more than one charge. In class, we're going to practice naming some compounds.